We're looking at section 13.4. We're talking about compound interest. So we're going to construct linear and exponential functions, including arithmetic and geometric sequences, given a graph, a description of a relationship, or two input-output pairs. So a bond is a type of investment that you buy with cash and for which you receive interest either as the bond matures or when it matures. A conventional bond generates an interest payment, sometimes called a coupon payment, on a regular basis, typically twice a year. The interest payments end when the bond matures and the amount you paid upfront is returned to you. A zero coupon bond, on the other hand, requires you to invest less money upfront and pays you its maturity value, which includes all accumulated interest when the bond matures. Over the life of the bond, the interest that is earned each period itself earns interest until the bond matures. So a basic difference between a conventional bond and a zero coupon bond is the type of interest earned. A conventional bond pays simple interest, whereas a zero coupon bond pays compound interest, which is interest that in turn earns interest. So for $1,000, you can buy a conventional bond that has a maturity value of $1,000, has a maturity date of 4 years, and pays 5% annual interest. Calculate the interest that the investment earns annually by completing the table. So the thing to bear in mind, interest earned is paid to you and not reinvested. So if you invest $1,000, you get a 5% return rate, which would be $50. But at the end of the year, you just get that $50 and your investment is still only worth $1,000. Same thing happens each year. You'll get $50 back, but your bond is still only staying at $1,000. Whereas for 822.70, you can buy a zero coupon bond that has a maturity value of $1,000, has a maturity date of 4 years, and pays 5% annual interest. Calculate the interest that the investment earns annually by completing the table. So keep in mind here that interest earned is reinvested and not paid to you until the bond matures. So if you start out investing $822.70, 5% return rate would be $41.14. So then the value of the investment, you take what you had originally, you would add in that interest earned, and it would be worth $863.84. So then year two, you take that $863.84, you find out what its interest earned. So you take that value, multiply by 5%, which would be $43.19, and then add those together. The value at the end of year two would be $907.03. So that's what you start with in year three. 5% of that is your interest, which is $45.35. Add those together. Your value at the end of year three would be $952.38. And then year four, you're starting at $952.38. 5% interest of that is $47.62. And then you add those together to get your maturity rate of $1,000. So if we think about the difference between how simple interest is calculated and how compound interest is calculated, simple interest is paid back and not reinvested. So it's a set amount each time. Compound interest is reinvested. So the value grows exponentially over time. If V of t represents the value of investment at time t, in whole number of years starting with t0 and ending with t4, write a constant function for the last column in the first table and an exponential function for the last column in the second table. So with the simple interest, our value of our function, our value of our bond was always $1,000. Whereas with the compound interest, it's a geometric series. or you could think of it as an exponential growth function, where our v of t would be the initial value, 822.70, times the rate, which would be 1.05 for that 5% interest rate, and then to the t. So if we're modeling interest compounded annually, we'll use the regular general exponential growth function. So f of t is equal to a times 1 plus r to the t. Or in our case now, we're going to use instead v of t. So v of t is equal to p, which is the principal, the amount invested, times 1 plus r, so that interest rate, and then to the t. So this is what happens if you're compounded annually. So a person invests $3,500 in an account that earns 3% annual interest. Find when the value of the investment reaches $10,000. So P, your starting value is $3,500. Sorry, your rate is 0.03, and so then our function would be 3,500 times 1.03 to the t. So you'll graph that. You'll graph a line at 10,000, and then see where they intersect. So in this case, the value of the function is 10,000, about 35.5 years. Person invests $200 in an account that earns 6.25% annual interest. Find when their investment reaches $5,000. So P is our starting value of 200. Our rate would be 0.0625. So then our function is going to be 200 times 1.0625 to the t. So we'll graph that function on the calculator and also graph the line at y equals 5,000. And then see where they intersect. So they've graciously given us the picture here. That intersection point is at about 53.1. So the investment reaches a value of $5,000 in about 53.1 years. A person invests $1,000 in an account that earns 5.5% annual interest. Find when the value of the investment has doubled. So our function would be v of t is equal to our initial amount, 1,000, times 1.055, 1 plus our interest rate, and then to the t. So we're trying to find out when does our function equal 2,000, because that's when it doubled. So that's the two things we'll graph on our calculator. So we'll have 1,000 times 1.055 to the x. And then we'll also graph the line at 2,000. So if we look at our window, I've got my x values going from 0 to 30, giving us a 30-year window. Y values. So we're looking for when it's 2,000. So I'm going to set my window between 1,000 and 3,000 with a scale of 200. And then we can see where these are going to intersect. So we hit second trace, number 5, tell what two lines we're using and our guess. And so at about 12.95. So our function doubles in about 12.95 years. So what happens if our interest is compounded more than once a year? So instead, we're going to use this function here. V of t is equal to p times 1 plus r over n to the nt. So n is now representing the amount of times per year that the interest is being compounded. So if it's being compounded semi-annually, n would be 2. If it's being compounded quarterly, n would be 4. A monthly, n would be 12. Daily, n would be 365. A person invests $1,200 in an account that earns 2% annual interest, compounded quarterly. So our function would be 1,200, our original amount, times 1 plus 0.02 divided by 4, all that to the 4t. So then if they wanted to see when it's going to reach $1,500, graph that function in the line 1,500 to see where they intersect. And in this case, that would happen at about 11.2 years. So come back to the next video for us to continue this lesson.